A key benefit of utilizing automated isometric drawings is ensuring consistency. The efficiency and cost-effectiveness gained from automation would be significantly reduced if each issued isometric drawing required manual adjustments. To prevent this, users can embed standard annotations such as floor penetrations, directional arrows, insulation indicators, and notes directly into the model. This ensures that every time an isometric drawing is generated, these details remain intact. These isometric-specific elements are found within the Isometric tab, not the Modeling tab. Now, let's explore the available options and incorporate some of them into our model. We'll start by opening Drawing 10_Model. First, I'll remove the external references, XREFs, to enhance visibility. I'll unload elements like equipment and structural steel so we can focus on the necessary components. Next, let's examine a specific pipeline. By right-clicking on the line and selecting Add to Selection, I can choose the connected line number. From there, I'll right-click again and access the Part Isolation tool to isolate the selected components. At this stage, we are only viewing the specific pipeline we want to modify. For better visualization, adjusting the display mode is useful. Switching the visual style to either wireframe or X-ray allows us to see placed components, which might otherwise be obscured in solid mode due to their alignment with the pipeline's centerline. Now, let's begin adding annotations. Starting with an isometric message, I'll select the ISO message tool, which enables the addition of custom notes directly onto the isometric drawing. These notes could include instructions for fabrication, installation guidance, or any other relevant information. For clarity, I'll enclose this message in a box and input the necessary text. The option to include dimensions is available. I'll select Yes to ensure the note appears with measurement details. Next, using Object Snap settings, I'll align this annotation with the pipeline centerline. Once placed, modifications are straightforward. Just double-click the annotation to edit its message or enclosure style. To demonstrate the impact of different visual styles, I'll switch back to realistic mode. As expected, the annotation is now hidden, reinforcing the importance of wireframe or X-ray views for this task. Moving on, let's add a floor penetration symbol. I'll reload the structural steel XREF to better visualize where the pipeline intersects the grating. Then, selecting the floor symbol tool, I'll place the penetration marker on the pipeline centerline at the grating intersection. Exact placement isn't mandatory, but precise positioning with dimensions is an option for those needing high accuracy. Once positioned, this penetration marker will appear in the isometric drawing, indicating that the pipeline passes through a steel grating. After placing the floor penetration symbol, I'll turn off the structural reference again and isolate the pipeline for further annotation. Now, let's add directional arrows. Using the floor arrow tool, I'll mark the direction of flow. The first arrow will be placed at the transition point where the pipe exits a vertical tank and moves horizontally. The software provides an option to confirm or reverse the arrow direction. I'll confirm the correct orientation. For efficiency, the tool allows repeated placements without reselecting it. I'll add additional arrows along the pipeline, including vertical and horizontal sections, ensuring clarity in the final isometric drawing. If an arrow is placed incorrectly, it can easily be reversed with a simple adjustment. Next, let's apply insulation symbols. Suppose insulation is required for a specific section of the pipeline. I'll select the appropriate pipe run, access its properties, and define insulation details under the general settings. We don't need to insulate the entire line, only a portion of it. To do this, I'll navigate to the insulation thickness settings and use the override mode to ensure we don't apply insulation to the whole line. I'll set the thickness to 2 inches. Next, I'll go to the Home tab, enable visualization, and turn on the insulation display. This will allow us to see which sections are insulated and which are not. Now, I want to ensure that the isometric ISO view accurately reflects this distinction. I'll add an insulation symbol to indicate the insulated side and leave the other side uninsulated. Additionally, I'll place a location point as a notation in our model. By double-clicking on it, we can specify what the location point represents or substitute it with another relevant symbol. For now, I'll leave it as a location point for reference. Now, moving on to the production ISO, we're working with line number 400. I'll adjust advanced settings to increase congestion and confirm the changes. Once that's done, I'll generate the ISO line. With the ISOs completed, I'll open the first drawing and review the results. In this particular ISO, we can see the insulation symbol has been added and dimensioned accordingly. This drawing also includes a floor penetration detail showing how the pipe runs through the steel grating. Other added notations serve as references for checkers, builders, or field installers. If needed, we can choose to include or exclude dimensions for these notations. Looking more closely, we can see the drop line extending from the bottom of the tank. By zooming in, we can observe the flow direction arrow, which ensures clarity on how fluid moves through the pipe. All of these elements, including flow arrows and notations, are fully customizable. If visibility is an issue due to line thickness, adjustments can be made during ISO setup. Once these elements are incorporated into the model, there should be no need for manual modifications. Each time we regenerate the ISOs, all the added details, notations, symbols, and dimensions will appear consistently in every output.